The next video clip that I have here really is a recap of what we just did earlier. This key concept graphs of rational functions. What you're going to be looking at is, if you look at this, this is x to the nth and x to the mth. They're going to use the n and the m to describe what I described to you earlier in the previous video, and that is, you're looking at the degree, and I'm really focused on the horizontal asymptote here to begin with. And if we want to know where the horizontal asymptote is, we really have to pay attention to the degree. So they're saying that n is the degree of the numerator and m is the degree of the denominator. If the numerator is less than the degree of the denominator, then you have a horizontal at y equals 0. If it's a tie in the degree, if n and m, the degrees of both of them are the same, the horizontal asymptote is at the ratio of the leading coefficients, and they're using a sub n and b sub m. Those are just your leading coefficients. If n is greater than m, which means the degree of the numerator is bigger than the degree of the denominator, then there is no horizontal asymptote. What they call it is an oblique asymptote. So we should make a differentiation between that, but it's a location of the n behavior. And if it's exactly 1 degree higher, then it's called an oblique. So if n is exactly 1 greater than m, we have an oblique asymptote rather than a horizontal. But we're going to put it underneath this horizontal asymptote concept because we're studying those degrees about the same way. So that's kind of what that was all about. They give us some more information here about trying to graph the function. So we'll go through this step by step and try to analyze each of these. So for each function, determine any vertical and horizontal asymptotes and intercepts, then graph it and state its domain. So when I do these, I really like to make sure that I always have them factored completely first. So I'm going to rewrite h at x if I can into factored form. This is going to be an x, then plus 3, and x minus 1. If I have this in factored form, it makes it a lot easier for me to find holes. It makes it a lot easier for me to find vertical asymptotes in particular. So the other thing that makes it very apparent is the domain. So I'm going to take care of that domain right away. The domain is any input that we created 0 in the denominator. So what are the related zeros in the denominator? And that is when x is equal to a negative 3 or when x is equal to a positive 1. So we want restrictions. X has got to be an element of real numbers such that x cannot equal a negative 3 and a positive 1. So that's the first part, is getting our domain set. Next thing, I'm going to pick that off, got the domain. Determine if it has any vertical and horizontal asymptotes. Well, the vertical asymptotes are going to be the same things we just got done looking at the domain. We're going to find vertical asymptotes at y equals and our related zeros to the denominator. So at y equals a negative 3, and we have another one at y equals a positive 1. So we have 2 vertical asymptotes in this graph. The next thing they want us to locate is the location of any horizontal asymptotes. So to study the horizontal asymptote, what we'll do is we'll look at the degree. Now this is kind of good to practice this. This one doesn't have an x in it, so this is a degree of 0. So this is a 0th degree polynomial, and this one is a 2nd degree polynomial. This is the one time it's easier to go back into your standard form or the original, and you can see those degrees very quickly. So the bottom is bigger than the top. So anytime the numerator is smaller than denominator, our horizontal asymptote is always fixed at 0, at y equals 0. So we have our n behavior described by y equals 0, horizontal asymptote, and now they're talking about the intercepts. So to find the x-intercepts, all we do is we look at what would it take to set the numerator equal to 0. Well, that's just a 2. There's no way to force a 2 to equal 0, which tells me there's no x-intercepts. So this graph will never cross the x-axis. Then the next part is figuring out if it has any y-intercepts. To figure out the y-intercept, we have to force the output to be equal to 0. So really what I'm going to do is I'm going to consider what would it take to create a fraction that is equal to 0. So over here I'm thinking 0 equals, I want the output to be 0. What are the inputs that I can use to get an output of 0? Now, the only way you can get a fraction, just a simpler version of this, to equal 0 is if the numerator can equal 0. The denominator can't be 0 or to be undefined. So the only way we ever get a fraction to equal 0 is if the numerator can equal 0. Is there any way that a 2 can ever equal a 0? And that is no. Can't happen. So that means there's no y-intercept. So there's no x and no y-intercept on this graph. Now in rational functions, if you have the horizontal asymptotes, the vertical asymptote, and you have the x and y intercepts located then you basically can draw a rough sketch of this graph. So now we want to draw a rough sketch of this. So the first thing I'm going to do is I'm going to sketch an X and Y axis. I'm going to put in the locations of a -3 and 1 for our vertical asymptotes. So 1, 2, 3, and at a +1. And I'll try to get those little doctored up with these. There's got to be a vertical asymptote at -3. There's got to be a vertical asymptote at 1. Slide it over just a bit. Now we have a location of a horizontal asymptote at y equals 0. I'm just going to use a little different color for that one. This one is our horizontal asymptote, which models the end behavior. We know our graph doesn't cross the x-axis, doesn't cross the y-axis. Now, to get a sketch of this, here's what I try to do. I try to pick, since this was at a +1, I want to know what our graph is doing by these vertical asymptotes. At the vertical asymptotes, your graph will either approach a positive infinity or it'll approach a negative infinity. So what I do is I pick a number that's relatively close to a +1. So I'm going to pick a number like a +2. Well, our numbers will be approaching a positive or negative infinity as we put in a +2. So I go back to this factored form, and I look at sign analysis. If I put in a 2, the 2 at the top stays 2 over, and then I put in a 2 plus 3, which is 5, times, and a 2 minus 1, which is 1, which is 2 over 5, or it's positive. So what we have is a curve that is coming from positive infinity, and it's going to reach up towards our positive infinity on our horizontal asymptote. Our end behavior out here told me it had to be coming from 0. So we're coming from 0. We're going to be approaching from a positive side all the way up to a positive infinity. Now I know this doesn't look like it's going towards positive infinity because it's only 2/5, but I don't need to know. I can keep getting closer. If you want to get in your calculator, you can put in a 1.1, you can put in a 1.01. But all we need to know is this thing going towards a positive value or a negative value? Because by vertical asymptotes, it'll do one of two things. It'll either go towards positive or go towards negative infinity. And it even gets easier than that. All I'm going to do is sign analysis. So rather than doing actual numbers, here's all I have to know. The numerator is a +2, so I put positive over the 2. Then I'm going to put in a +2 in for x. So if I put in a +2 for x and I add 3, it'll be positive. If I put in a +2 for x and subtract 1, it'll be positive. So I got a positive over, and a positive times positive is positive, and a positive divided by positive is positive. Well, that tells me it goes towards positive infinity. Sign analysis, not specific numbers. So here's what normally happens around vertical asymptotes. If your graph went to positive infinity on the right side of this vertical asymptote, then typically on the left side of the vertical asymptote, it'll be coming back from negative infinity. Now I'm going to do a sign analysis. I'm going to pick a number that's a little bit smaller than 1. Maybe I can pick 0. So if I put in 0, well, 2 is still going to remain positive, just sign analysis. If I take 0 plus 3, that is a +3, but all I care about is a sign. And then the sign analysis, if it's 0 minus 1, that's a negative. So I got a positive on the numerator, and I got a negative on the denominator. Because positive numbers times negative are always negative. And a positive times negative is negative, so it's coming from negative infinity. So our curve is coming from negative infinity, coming up and approaching our horizontal asymptote. Next thing I want to do is make sure I know what's going on by the next vertical asymptote. Okay? Now, we already have decided there are no x-intercepts. So this graph, what we don't care about is how high it comes up, but what I do know is it cannot cross the x-axis, and it's going to come back down here towards negative infinity by the next vertical asymptote. Now, that was at a -3. I'm going to show you some sign analysis, and that better go towards negative infinity. Keep in mind, we're going to put a number that's close to a -3 on the right-hand side. So I'm going to test something like a -2. So the numerator can't change. It's a +2, so it's positive. You put in a -2. A -2 plus 3 is a +1. So all I need is a positive. A -2 minus 1 is a -3. All I need is a negative. And it's going to, again, be a positive divided by a negative. Make sure I write that in there correctly. The top is positive, the bottom is negative, so all we get is a negative output, so it's going towards negative infinity. Okay? That's when we went from the right side. If we come back from the left side, keep in mind, our behavior by vertical asymptote is normally opposite. So if it's on the right side going towards negative infinity, then on the left side of this, it should be coming from positive infinity. So I'm going to do some sign analysis on it. All I got to do is pick a number that's a little bit bigger than a negative 3, such as a negative, a little smaller than a negative 3, which is negative 4. The 2 can't change. It's going to stay positive. I'm doing sign analysis only. I'm just going to compare the signs. Negative 4 minus 3, that's a negative 1, so that's a negative answer. Anything on this side will be negative, and the negative 4 minus 1 is going to be a negative. The negative times negative is positive, and positive divided by positive is positive. So it is indeed coming back from positive infinity. So I'm going to clear that off. So it's coming down from positive infinity. It cannot cross the x-axis, and it has to go towards 0 on the end behavior. So there's my sketch of this graph. It's a rough sketch. What we don't know for sure is the height of this. It could come up in here and not quite as high, but you don't have to worry about that. You just have to have the general shape. Okay, so there's our first sketch of a rational function. I hope some of those things that we did last year are still with you and that they're coming back a little bit to you. So we'll practice this again on the next equation. In the next equation, first thing I want to do is I want to set up the factorization. So this is x and x, factors of 2 that are 1 apart, so we better go plus 2 minus 1. So now I have the denominator factored. So this is our n at x. Our domain. Okay, first thing I noticed, there aren't any factors that are identical on the top and the bottom, so there's no holes. The only part that I have to worry about in our domain is don't divide by 0. So if we're looking at the set of real numbers, they better be numbers such that x does not equal. The related 0 to this factor is a negative 2. The related 0 to this factor is a positive 1. So do not let x equal a negative 2 or a positive 1. Next thing we're going to do is we're going to look at the vertical asymptote. In order to find the location of the vertical asymptote, it's basically what you just got done doing. What are the inputs that will create an output of, or a domain of 0? Let me say that again. What are the inputs that we can put into the denominator that would cause a division by 0? And that means we could not have x equals a negative 2. So at x of negative 2, there's a vertical asymptote. Another value that x can equal is x equals 1. So there's a vertical asymptote at x equals 1. So we have 2 vertical asymptotes in the graph again. Next thing we're looking for is the horizontal asymptote. Okay, again, this is a matter of degree. It's a first degree polynomial this time over a second degree polynomial. If the bottom is bigger, it's always at 0. So if the numerator is 1 less, or the numerator is less than the denominator, we always have a horizontal at y equals 0. So same as we had last time. And the only other thing we need are the x and y intercepts. So the x-intercepts. To find the location of the x-intercepts, you take what's left in the numerator and you set it equal to 0. Well, that's simple. If x is equal to 0, we'll have an x-intercept. The next thing, the y-intercept. The y-intercept is whenever we force the output to be equal to 0. So I'm kind of thinking of it like this. I want this output, or the n at x, to equal 0. The only way a fraction can ever equal 0 is if the numerator is equal to 0. So our y-intercept in this one is the same. It's when y equals 0. So we have the origin as being the one location where it crosses the axis. So we can go about getting our sketch of our graph. So let me hide that for a moment. We're going to put in our x and y axis and sketch a graph. Here's our y. There's our x-axis. We're going to put in the locations of a negative 2, negative 1, negative 2. Then we also need one at positive 1. So I'll put in a horizontal or vertical asymptote at a positive 1. A horizontal asymptote we set is at y equals 0. Okay? And now I'm going to work from one of these asymptotes. I typically just pick one of the asymptotes and start working towards it. So if I work towards this asymptote, since it's at a positive 1, I pick a number like a positive 2, and I do sign analysis. Sign analysis just says, what is the sign on any value that I pick to the right of a positive 1? So if I pick a 2, it's a positive 2x, so just 2, or positive 2 in for x, so it's positive. I put in a positive 2. 2 plus 2 is a positive 4. All I care is it's positive. And I put in 2 minus 1. 2 minus 1, that'll be a positive. So it's positive divided by positive, which means our graph has to be going towards positive infinity. So once again, our graph, the end behavior is coming from 0. It's coming up and it's trying to reach and go towards positive infinity. Now we're on the right side of the graph, it's positive infinity, so when we come back on the left side of our vertical asymptote, we should be coming from negative infinity. So here we come from negative infinity. If we do a sign analysis just quickly, you can see that I can confirm that I know it's coming from negative infinity, so we pick a number like 0. Better not pick 0 because that makes it completely undefined there on those, so we're going to pick a number like half. It doesn't matter, 1/2. If you put in a half for x, that's a positive half. If you put in a half for x and add 2, it's a positive 2.5. If you put in a half for x, a half minus 1 is a negative. So it's positive divided by a negative, which means we get a negative, and it's coming from negative infinity. So here's our graph coming from negative infinity. Now what's different on this one, we have a crossing on the x-axis. So it's got to cross the x-axis. The x-intercept says it has to cross at 0, and our y-intercept says it has to cross at 0. So here we are crossing through the origin. Now, it can't cross again. There's only one x-intercept, so now it has to approach this vertical asymptote towards positive infinity. There's no other way this graph can come back down without crossing the x-axis, because we're limited to just one of them. If it's positive on the right side, then on the left side it's coming from negative infinity, and now it's going to go all the way out towards our horizontal asymptote at 0. No more crosses on the x-axis. And again, just a quick sign analysis. Since this was at a -2, if we were to put in a -1, I bet we would find that it's going to go towards positive infinity when we're just to the right of this vertical asymptote I'm looking at here. So put in a -1. -1 for x makes that a negative. In the numerator, put in a -1 plus 2. -1 plus 2 is going to be a positive. And any number in between here will always give you a positive. So any number in between these. And then if I put in a -1, -1 minus 1 is a negative. So that means you got a negative divided by another negative, which ends up being a positive infinity, just like we have drawn on our graph. So there's some thoughts on finding the domain, vertical and horizontal asymptotes, x and y intercepts, and also how I can use sign analysis to help us sketch a graph of a rational function.